In lesson 8 here, we reviewed how we factor trinomials, and I kicked it up a notch by showing you this new method of factoring, possibly showing you this new method of how to factor them. But it's a skill that is assumed that you mastered in Algebra 1. This day just gave us some time to work on it. So you should be able to fluently do these 6 homework problems, but here are my solutions to them. So factor the following polynomials completely. Like always, we're factoring things completely. So I have 6x squared plus 48x plus 90. You could start by doing the AC method on that, and it would be a disaster. Could be done, but always look for a GCF. All of those numbers have a 6 that I can factor out, so I'm going to factor out that 6. If I take out a 6, I'm left with 8x plus 15. And we like factoring quadratics like this when there's a 1, because all we have to do is ask ourselves what multiplies to 15 and adds to 8. What multiplies to 15 and adds to 8? Well, that's plus 3 and plus 5. So we are done factoring there. So we like it when we have that leading coefficient of 1 because they're pretty easy to factor from that point. What multiplies to the constant, the plain old number that adds to the coefficient of x. 3x squared plus 4x minus 20. Do we have a GCF? We don't. 3, 40, 20, nothing I can take out there. So we have to apply the AC method. Instead of saying what multiplies to negative 20, we're going to say what multiplies to negative 60. 3 times negative 20. What multiplies to negative 60? That adds to 4. So you have to stop and ask yourself and say, self, what multiplies to negative 60 that adds to 4? And I tell my 9th graders this when I teach them factoring from the first time. You cannot just sit there and stare. You actually have to be thinking, pick up a calculator and do some trial and error. You might not get it right the first time. You have to try. 1 in 60 doesn't work. 2 in 30 doesn't work. 3 in 20 doesn't work. 4 in 15, no. 5 in 12, no. 6 and 10. 6 and 10 looks promising because I can do a positive 10 and a negative 6. So I'm going to split that middle term, 3x squared. I'm rewriting 4x as 10x minus 6x. That is a legal move to do. I can rewrite 4x as 10x minus 6x. They're equivalent. Now that I have these terms here, I'm going to factor out from the first two. What can I take out? I can GCF out an x. Now it's just a bunch of GCFing. Well, I need a 3x plus 10 to end up over here. What can I GCF out from the second two terms? I can take out a negative 2. So again, it's equivalent. All I'm doing is applying the distributive property in reverse. I split the middle term. Now I'm undistributing those two groups that I made there. Well, what's my new GCF? They both have a common factor of 3x plus 10. And I'm left with x minus 2. That's how that trinomial factors. It's something you need to get quick at. You could do the guess and check method if you like that, but guessing and checking takes a lot of time. This will always give you the correct factorization. 4t squared plus 25t plus 25. Is there a GCF? No, there's nothing I can factor out. So I need to ask myself, self, what multiplies to 100 that adds to 25? What multiplies to the product of the leading coefficient and the constant, 4 times 25, that adds to that middle term? What multiplies to 100 that adds to 25? Well, 20 times 5 works. So what am I going to do? I'm going to take that middle term and tear it apart. I'm going to tear 25t into 20t plus 5t. That middle term, I split apart, I pulled it apart, and I got this expression now. I look at my first two terms. What can I take out? What can I undistribute? What can I GCF out? A 4t, t plus 5. I better end up with a t plus 5 over here. What do I need to GCF out? I need to take out a positive 5. That does check. My new GCF now is t plus 5. 4t plus 5 is left over. It makes sense that we're undoing the distributive property because when we multiply, all we're doing is distributing. So to factor, it makes sense that all we're doing is taking the GCF, we're undoing the distributive property because that's what we did to get that 4t squared plus 25t plus 25 from the product of those two binomials. Moving on, 5x cubed minus 41x squared plus 8x. Well, it's a trinomial. but there's a GCF of an x that I can factor out from all those terms. Always, 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 I can't say it enough, take out a GCF at first. Makes your life easier. Now you have to ask yourself, what multiplies to 5 times 8? What multiplies to 40? That adds to the middle term, negative 41. What multiplies to 40 that adds to negative 41? Well, negative 40 and negative 1 work, so I'm going to split that middle term. I'm going to take that negative 41x and rewrite it as negative 40x minus 1x. Don't forget that you actually have to bring everything else down. And don't forget that it's not just negative 40, it's actually negative 40x, because that's what that middle term was. GCF, from the first two terms, I can take out a 5x, and I'm left with x minus 8. So I need an x minus 8 over here, so I'm going to have to take out a negative 1 from those two terms. Distribute that in, it checks. So my factors are x minus 8, that's my new GCF that I'm taking out. Notice that there's just one of them, it's not squared, I undistributed that. And I'm left with 5x minus 1. Oh, but wait a minute, who comes along for the ride? That x comes along for the ride, that original GCF still is there. Don't lose your GCF that you lost in the beginning. He matters, he's important. Two more and we call it a day. 8m squared plus 20m minus 12. Well, hold on, before I start doing the AC method there, let's notice that there's a GCF. I can take out a 4 from everybody. I'm left with 2m squared plus 5m minus 3. Okay, I still have to use the AC method, so I have to ask myself, what multiplies to negative 6? That adds to 5. The 5s and 6s are tricky because there's a lot of combinations that you think work but actually don't. Multiply to negative 6, add to 5. Well, they have to have opposite signs because they multiply to 6, negative 6. That's a negative number there, so they have to have opposite signs. It comes out to be 6 and negative 1. Yes, that works. So you can keep that 4 coming along for the ride so you don't lose him. Split up that middle term. Split up that middle term as 6m minus 1m. Look at the first two terms. What can I take out? My GCF is 2m. I'm left with m plus 3. I need an m plus 3 over here, so what do I factor out? A negative 1. I know the parentheses are probably driving you crazy, but that's okay. That 4 comes along for the ride. M plus 3 is my new GCF, and I'm left with 2m minus 1. That expression is equivalent to 8m squared plus 20m minus 12. If I were to remultiply these binomials together times 4, I would get that original trinomial I started with. They're equivalent, they look different, they look different, but they have the same value. That's what factoring does. We create equivalent expressions that just look different, and they're written as a product instead of as adding and subtracting monomials together. And finally, the last one. It's a trinomial, but it's a little different because it's got an x to the fourth and an x squared, but that doesn't matter. It's still a trinomial. I factor trinomials the same way I factor any trinomial. Is there a GCF? No. So I ask myself, what multiplies to 9 times negative 4? What multiplies to negative 36? That adds to 35. What multiplies to negative 36? That adds to 35. That looks like 36 and negative 1. Yes. So I have 9x to the fourth. I'm splitting up that middle term as 36 minus 1. So 36, not x, because he was an x squared. I'm just taking that middle term and tearing it apart. Minus 4. Okay, let's see what I can GCF out from the first two. 9x squared, right? X to the fourth and x squared. I can take out 2 of those x's, and I'm left with x squared plus 4. Yes. 9 times 4 is 36. Good. So I need an x squared plus 4 over here. Can I get that? Yes, if I take out a negative 1. So my new GCF is x squared plus 4. We're going to factor that out from both of those two terms, and I'm left with 9x squared minus 1. And you're like, I did it, coach. Great, you did factor the trinomial. However, I always like things factored completely. We currently cannot touch x squared plus 4, so we'll leave him alone for now until we get to Unit 3. I know you're dying to know what happens in Unit 3. You'll find out. It'll come eventually. Um, oh, warning, warning, warning! 9x squared minus 1, that's the difference of perfect squares. 3x plus 1, 3x minus 1. That's factored completely. So getting to here was a big step. That was factoring the trinomial, but we can never let our guard down for looking for GCFs and the difference of perfect squares. Hopefully you remember how to factor trinomials. Hopefully I might have taught you something in this lesson and didn't waste your time, but we need to get fluent at practicing at factoring trinomials. It's such an essential skill going forward for your mathematical career, especially if you're in Algebra 2 and are pursuing future mathematics courses. See ya in Lesson 9.